we have two blocks of equal mass m, and they are tied to each other through a light string. One of the blocks is pulled along the line joining them with a constant force F. Find the tension in the string joining the blocks. So we have two blocks, both having mass m. They lie on some surface. No talks about friction. And let's say this block is pulled by a force F. Now you need to find the tension in this string. So whatever tension is exerted here is also exerted here, since this is a massless string, and you can assume this for massless strings. And so what that means is that whatever motion this block exhibits, let's say this moves with a speed of 5 meters per second, then this block must also move with a speed of 5 meters per second. And if this block has an acceleration a, this block must also have an acceleration a. So this means this force F induces an acceleration a on this entire system. So that means if you take this entire system in Wyatt, that means that F, which is the sum of all the forces acting on this Wyatt system, that is equal to 2m, the sum of the masses of the system, times the acceleration a that the system A exhibits. And so that means that in terms of F and m, you can write A to be equal to F over 2m. So far, so good. Now, if you take these two separate blocks, if you take the first block, so this is the first block, this first block has two forces acting on it. There is the F horizontal force, and then there is the tension. The sum of these two forces must give you an acceleration in the right direction, and that acceleration should be equal to F over 2m, since that is the acceleration for the entire system. So the sum of forces acting on m, that is equal to F minus t, since this is the positive direction, and F minus t is equal to the mass m times the acceleration by Newton's second law, so F over 2m. M and m cancels out, and you get t to be equal to F minus F over 2, or just F over 2.